Hybridization is the blending of orbitals on covalent bonds. Bonding occurs when half-filled orbitals overlap. So as we can see here, where our methane has a carbon in the middle and then the hydrogens on the outskirts, we have a bonding that's going to occur with these half-filled orbitals. So this one probably wants to bond with this one, and this one probably wants to bond with this one. But this leaves two extra hydrogens that are not going to be overlapping, which means they're not going to be stable, not going to be happy. So what are we going to do? Well, we're going to have to change our essential carbon to change its hybridization. So its shape right now, it's a tetrahedral because there are 4 bond segments, as you can see, which means that would be tetrahedral. This would be 5 bond segments, this would be 6 bond segments, etc. So because we're dealing with a tetrahedral, this is a 4sp3, which means we have 4 sp3 orbitals. So we're going to draw 4 of them, and each one's going to be labeled as an sp3. sp3 just means if there's 3 p's, that means 75% of it is p and 25% of it is s. Now that we can do the carbon, all 4 of these valence electrons are going to be in play, so that all 4 of these hydrogens can be in play as well. All 4 of these are going to be stacked that way. Now they can easily bond with the hydrogens, and each one is going to be sigma bonded. Sigma, 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 sigma. Whenever we are dealing with just a single bond, it's always going to be a sigma bond. So here, again, we dealt with a tetrahedral, and we have 4 sigma bonds. Next, we're going to be looking at CH2O. Well, carbon is going to be in the middle. So carbon, again, has 4 valence electrons. But what kind of shape is this? 1, 2, 3. There are 3 bond segments, so it's going to be a trigonal planar, which means it's going to be a 3sp2. So we're going to draw 3 orbitals. Each one's going to be an sp2. We're going to put those 3 electrons onto here, but there is one last electron here. Where are we going to put it? Well, we have to add one more orbital for there. So that's where that electron is going to be sitting. Now, oxygen, it's going to be sigma bonded because the first single bond is always going to be a sigma bond. This is going to be a sigma bonded first, so this is going to be bonded through a sigma, and then the second of that double bond is going to be the weaker one, so it's going to be a pi bond. So it's going to go to this one because it's not the main one, so this is going to be a pi bond. It's going to be weaker because it's sideways crossover. It's not as strong. And then we're going to have our 2 hydrogens here. They're both single bonded, so they're both going to be sigma bonded. So this is going to be a sigma, and this one's also going to be a sigma. That's about it. So now this is going to be our trigonal planar shape. And we have 3 single bonds, and we have 1 pi bond. Now, based on our single bond here, it's always going to be strong because it's going to be sigma bonded. And then, again, this one's going to be the strong one as well. It's going to be sigma bonded. But then our second one, right, is always going to be the pi bonded. So this one's going to be weaker. And whenever we look at the pi bonds, they're going to be on both sides just based on electron density.